Most of the AI workload being developed today is going to be on Kubernetes. And in case you are working on Amazon, the only option you have is Amazon EKS. In this video, we'll talk about how to set up your own Amazon EKS lab and some of the container security basics you would need to work on before you can start working on building security for Amazon EKS. For this particular video, I have Anjali and Divyanshu who are going to walk you through this. Both Anjali and Divyanshu are senior security engineers and in their own right have been talking about Kubernetes in Amazon for a long time. So I could not think of better people to talk about this particular subject. They have created this as part of Advent.Cloud Security. So you'll get to see the entire video there on Advent.Cloud Security Podcast TV as well. Let's get into the video.
Welcome to our session AWS EKS Security Masterclass. I am Anjali Shukla and I have Divyanshu with me. Together we have created EKS Goat, which is a vulnerable version of AWS Kubernetes service. And here we have included an attacking and defending scenario, and we will start from the basics. So don't worry, this class is definitely for the beginners as well. Before sharing the agenda with you, I would like to share the prerequisites. So you need to have two things. One, a GitHub account with the code spaces. So we'll be using a code space functionality of GitHub where we can run the command directly. We'll be getting one terminal where we'll be running various commands. So you don't have to go anywhere or you don't need other terminal. Second, we need to have an AWS account with administrator access, as we'll be deploying lab, creating a cluster, creating an IAM roles and the other resources as well. So for that, you need an AWS account. So these are the simple two things you would require before starting with the lab session. Coming to the agenda, we have divided this masterclass into 4 parts. First section where we will create the IAM users and the setting up the lab environment and discussing the container security. Second, we will discuss the ECR and EKS. These are the two services in AWS. First is the Elastic Container Registry and Elastic Kubernetes Service. These we will discussing in this section too. And we have 2 lab scenarios as well. Third and the most interesting section is the attacking section. So we have developed a vulnerable application for you. So where we will try to do the hands-on, and we have 6 to 7 labs, and which starts basically it follows a flow. We'll be enumerating the environment and then gaining access to the application and then try to escalate our privileges. And the interesting part is we have included the CV as well. The recent CV we have included in this attacking section. And lastly, we'll end with the defense section. So where we will discuss the defense strategies like runtime security, guard duties, and how to automate the security of your Kubernetes cluster in an automated fashion. Lastly, I would like to introduce myself. I am Anjali Shukla, Senior Security Engineer, and I have expertise in AWS, GCP, and DevSecOps. I am founder of Kubernetes Village and an AWS community builder, and active Bangalore chapter leader of W3-CS community. That's it about myself. I would like Divyanshu to introduce yourself and start with the session.
So thank you, Anjali. I and Anjali together we're going to follow this AWS EK Security Masterclass. We'll be diving into basics, and then we'll talk about AWS ECR, EKS exploitation, and then defense and hardening. So we have divided this into 4 sections. In the first section today, we are going to talk about setting up the GitHub code space, creating the IAM user, so that everyone who's even getting started, right, those who are new to AWS, they also know. And later we'll be going into the security of EC2, S3, and your ECR, EKS, IAM. We'll talk about privilege escalation, pod to node breakout. So there are much more scenarios than you can expect in lab. This will follow a flow from AWS EKS takeover. Will follow entire flow where attacker exploits application running with a CV and then later takes over the infrastructure. So definitely it is going to be fun, and I want you guys to follow the labs. This is a walkthrough kind of a scenario where we have given everything in the documentation, and this is the website, and I'll also show you the repository. So let's get started. And as a disclaimer, do not try this anywhere else where you're not authorized to. Please make sure that you are deploying this in like a testing lab or in a new AWS environment. Do not deploy this lab in the production. This is for the community, and this is not authorized, or this is not associated or endorsed with our employers or any other corporate entity. So let's get started. So if you'll see here, this is my GitHub repo, and this is associated with the Kubernetes Village. So we have created this EKS code. So, and thank you Beatsides Ahmedabad for giving us the opportunity. When we set up this masterclass, we got great feedbacks and we modified it accordingly. So if you have already attended that session, here you will get a better idea about the starting point in the AWS ECR and Docker security and defense and hardening part as well. Let's quickly move forward. And this is the website. You just have to click on it and it will open. It's hosted on Netlify. So you might see some kind of error. If you are facing some kind of error, please disable your VPN. I'll just close this for now. And I have my AWS account ready, and you need to have an AWS account with administrator privileges and billing enabled. You will be charged for AWS EKS. AWS EKS is not free. However, other components are free. Like if you are going to use it for 1 day or 2 day, you won't be charged. So I'll log into my user. I'll use the cloud user, and then I'll paste the password. And please make sure you are not using root credentials. Like you should always create another user and use it for accessing your AWS as a security best practice. So I'll click on this IAM service, and then on the left you can see there is this users. So I'll click on this user, and admin is already there. So I will go ahead and delete this. I'll type it very quickly and I'll recreate this. So I'll create this user again. So I'll type in admin, click on this provide user access to AWS Management Console. AWS Management Console is nothing but the UI, and then I'll enter the password. For now, I'll use a simple password. You need to make sure you are using a difficult password which is hard to brute force, or you can use a passphrase. I'll just disable or untick this user must create a new password at the next sign in. Although we are not going to use AWS console for this lab, and then you have to search for admin and select the AWS manage administrator policy, and let's click on create user. Just review it, click on create. You have the user ready. You have to click on view user. Although make sure you download this CSV and copy this username and password, and make sure to store it somewhere safe. I'll just continue because we don't have to log in. I'll quickly go to the security credentials on the right side, scroll down, and you can see the access key is 0. So we'll need access key and the secret key. So I'll quickly go ahead and click on this confirmation. I understand. You can select anything. I'm just selecting the CLI, and then I'll mention EKS security, EKS. You can add like any description tag. I'll click on create. I'll copy paste these two values and save it somewhere safe. I'll paste the secret key as well. And once you have created your user, you need to go back to your repo and you can fork it. I'll suggest to fork it. If like fork is already present, like in this case it is not, then you do not need, you need to sync it. If it's not present, like you are doing it for the first time, make sure to create this fork. So this is my test account, so I'm just forking the repo. You need to have a local copy, and it is recommended because in some cases we keep on adding new content or removing or modifying these things. So if something is missing, we will figure it out, or maybe someone reports to us that this step or command needs to be updated. Right? In that case, if you are running the lab, your lab might not work. So that's why we want you to have a fork, so that when you are running the GitHub code space, it uses that specific code which you have. So let's click on this create code space, which is next to clone part, and it will open a GitHub code space for you. We'll wait for this to come up. I'll close this AWS console. I'll scroll this up. So it will open a terminal. You have to wait for them. And I'll move to this part. The rest is more or less just the description. So I'll just quickly go to this setup IAM user. So we have covered all this. We have already created the keys. We have created a new user, added to a permission, created the user, and downloaded its username and password. Then we created an access key and secret key. And at the bottom, if you'll see, we already have a guided walkthrough for this GitHub code space creation. Specifically, it's a short video where if you want to know if you are facing any difficulty, if you don't know what privileges need to be added, then you can follow this. Then next is the GitHub code space setup. So like the repository is also mentioned here, you just need to fork it and then create a fork, create a GitHub code space. So I've tried to add as much as possible. However, if something is missing, just make sure to read the like mentioned line of the explanation, and you should be good to go. So it will create a VS Code like environment for you, and from here you need to copy paste these commands to follow the lab. So I'll just click on this copy and I'll start pasting. You can close this repo as well. It's not required once you have a code space. And then you can see I did an ls. There are a couple of files. I am inside the EKS directory, and then again I'll do ls. So for now we need to deploy this pre-deploy.sh bash script. So I'll make the script executable. I'll zoom in, slide it to the left, and I'll do a chmod +x, and then I'll source it. and source pdeploy.sh. It will run. We have to wait. Next is AWS configure. So once this setup is done, you can meanwhile you can go on the left side and you can look at the this sh script what's getting installed. You can see AWS CLI is getting installed, EKS CTL is getting installed. Its next is kubectl, Terraform, and JQ and other required components. So it's a very simple binary. You need to wait. By the time this is complete, we need to make sure we have our access key and the secret key handy. It's almost done now. It's installing Terraform. We'll be using Terraform. We have bash script, we have Docker file. So I've given multiple components here so that when a user or who is someone new is like installing it or setting this cluster for the first time, they should be able to see different ways of setting this infrastructure and what are some places, right, where you can look what needs to be fixed or these kind of things. You can definitely go and check out. I'll clear my screen and do a control V. It will ask for me the access key and the secret key. I'll quickly go and paste this same, set the region as east1, and so this is done. Next is AWS STS git caller identity. So I'll paste this command. It just gives me an output where we have an user ID, account ID, and ARN. Account is the account which I'm using. ARN is the identifier used by AWS to identify which component or like which object this is. So it's a user with the name of admin in the account 73033562150, and then IM is the service. So as we'll move forward in this lab, these user might change or this account might change. So do not worry, because we'll be like recording this like as we'll move forward. So in some cases you might not have the same user, but the permissions will remain same. Cluster name might change, so you do not need to worry. Just follow the steps. So if you are doing it again and again, or you might deploy something today and tomorrow you might use a different account, so in those cases these values will change. So you just need to follow the walkthrough. You just need to stick to how it is working, and just don't focus on any specific username or like like I created admin user, so you can create any other user as well. So this will deploy an EKS cluster, and whatever is required, it's already present in the script and the Terraform code, so you not need to worry about that. So just make sure if any name, anything changes, right? If you'll see on this window here, I'm using US West 2, but when I configured, I use US West East 1. Just make sure that you are following the concepts, not the keywords. And here also we have a guided setup for this. So this completes our basically AWS IAM user creation and your GitHub code space setup. Next is Docker. So now from here, we'll talk about Docker, container security, how Docker images and layers work. And then we'll talk about Docker namespace and the C groups and Docker secrets. Then we'll talk about static analysis of Docker containers. So let's get started. So first is Docker. Docker, what is Docker? Like what is container? What is the difference? Container is basically the special environment where you run everything packaged with code, libraries, and settings. And the tool which is used to manage this container is called as Docker. And why we use Docker? So Docker is used for consistency, ease of deployment, efficiency, and scalability. So when we are talking about thousands and thousands of clusters running multiple containers at any point of time, we need to make sure that these things are managed, scalable, and they are obviously secure from vulnerabilities and misconfigurations. What is the difference between this virtual machine and container? So let's take an example. If you remember, virtual machines, they use hypervisor, and first you have to download a virtual machine, VirtualBox, or any other similar tool, and then you go ahead and install an operating system onto it, and then you boot an operating system. So it takes some amount of RAM, your hard disk, and then you probably install your application. So it's like a foolproof operating system. Next thing is containers. So what is container? So let's take an example for containers also. So assume that there's a ship which is importing and exporting things from one place to another, and on the ship we have multiple containers. So in one container we have a fish, and which is transported maybe from somewhere different continent to a different continent, and you need to have refrigerator if like you want to store the fish so that they are not stale, right? And you need to have some electricity. And now the same electricity is shared to another object or container on the ship, which is also exporting papers or newspapers or magazine. It needs a warmer environment. It needs hot light, hot bulb, so that there is no moisture, right? So there also you need electricity. So electricity is something which is shared. However, they do have a different environment for each of. And now we have one single captain, we have one single crew, which is managing the entire thing. So in virtual machines, we were like sharing everything. So you can assume like having two ships divided in half, and then two captains and then two crew are doing the same thing, which is not required. You can have one container, you can have another container on the top of that stacked on it. It can be used, right, very easily, very efficiently. So this is how the Docker works. So basically this is how the container works, and the tool which is used to manage all this is called as Docker. So what are some advantages and disadvantages? So advantages, like it solves your dependency issues. You can set up the environment and you can run it. You can have a Python container, you can have a Linux container, you can have a specifically Ubuntu or Nginx or anything you want. You can package the image and the library and the dependency and create one image, and you can store it. So anyone who wants to use the same thing, right, it will be easy for them to run and deploy it. It solves your cross platform problems, and it is very scalable and efficient. So what are some disadvantages? So in disadvantages, it's more, there is not less GUI support, like there is not much of the GUI support. So next is Windows, like there is less Windows support. And obviously the security concerns, you have to manage thousands of virtual machines, and these machines are not just one single clone, right? They have different services. Some are running Ruby, some are running maybe PHP, Python, and you have to make sure that these things all are fixed, and the supply chain or the libraries and the dependencies are all fixed as well. Next is host security. You need to make sure the host on which these containers are running are secure as well. What is the architecture of the Docker? So Docker uses client server architecture. Like it is very much similar to how AWS CLI works. So it talks to AWS services using the API. So similarly, Docker client uses like APIs to interact with Docker daemon, which is running on the host. And it does all the heavy lifting, like building, running, distributing, and pulling images from the registry and all these things. And the third part is Docker registry. So Docker registry is nothing but something similar to GitHub, where you store your code. Similarly, in Docker registry, you store your registries or the image. So if I'll search Docker Hub on the Google, you will see that this portal, which is hosted, like which is under docker.com, it is basically the place where all the images are stored. So if I want to have an Nginx image, I can just search the Nginx and I'll have the image with different tags and the command. So by default, Docker uses latest tag. However, if you are not mentioning any tag, it will go to the Docker Hub and it will try to pull the latest tag. But specifically, you can mention these tags. Tag is nothing but the versioning of different Docker images. So let's start with the hands-on part. So first command is docker -- version. We'll see whether our Docker command is running fine or not. It gives us the response. Next is docker run hello world. So this is how you will run any Docker image. Like if you want to run an image and convert it into a container, you just need to do this docker run hello world. So it will pull this hello world image, and then it creates a container out of it, which is a running object of that image. So image is nothing but a blueprint, which is a template kind of a thing. And then from that, you can create any number of containers. So you will see here, first it tries to search it locally. If it is not able to find, then it is pulling from the library. So by default, it is pulling from Docker Hub. You need to explicitly change this if you want to pull it from somewhere else. We have different registries like AWS container registry, GCR from Google, and like this and other as well. So next is, if you want to run some Python specific or any language specific container, you just need to pull that image. I showed you already. So you can do docker pull. So you do not need to remember these names, these versions, by the way. You can just search it on Docker Hub to find out the exact versions present. These are called as tags. Next is this command to run it interactively. So docker run -itd python :3.8 slim bash. So docker run is the command to run any image. I is for interactive, T is for terminal, and D is for daemon. And then name of the like whichever image I want, and then I'm passing the command so that my container is running with bash at the end and it's not stopping, right? Because there's no tool or no process running, so it will exit. So next is docker ps. So docker ps is the command to list all the Docker process running. So you can see there is only one container with the container ID 1FC. It's basically the SHA value. And then if you want to stop the container, so the easiest way is docker stop, and then you have to pass the container ID. Since I just wanted to create the lab where I'm just stopping one single container, I've used the one liner which is present. So you'll see if I'll pass the ID, it will stop the container for me, and the same I am doing with this command as well. So let's wait. So you can see it has successfully exited. And now if I want to stop, I can run the same command, but since I've already stopped it, it is showing me the error. So this is not an error. This is the intended way. It is just that I showed you guys how to, like, what is this entire value coming out to be. Next is if I want to remove the Docker container. So I'll pass this. And if I want to remove the images which are present, so if I run this docker images command, you will see there are two images which we pulled, and if I want to delete Python one, I just have to pass the name or the ID, and now if I'll do this, only Docker world is left. So this completes our introduction to Docker. Now in the next section, we'll talk about container security. So container security, why we need this? What is this container security? So container security is about protecting applications running inside the containers. It's also about securing the infrastructure from vulnerabilities and misconfiguration. And we need to make sure the host on which this container is running is also secure. These approach will change when we are talking about containers instead of the on-premise servers or the data centers, because here we are using containers which completely rely on different tech, and then like all the functionalities and everything is different. So these are some ways like why we need basically this container security is because of the complex architecture, cluster deployment, multiple layers, and then different process. What are some key areas of container security? So this is what you have to focus when you get started. So first is container image, then container repositories, then container runtime, and container host and orchestrators. So I'll start from the bottom one. So what is this orchestrator? Orchestrator is nothing but a tool which is used to manage these containers. So you are just focusing on one container, right? So in reality, there are thousands of containers which are running, and how we'll manage that? How we'll make sure that if some container on some XYZ machine exited, how we'll redeploy it? Either you will go and do a docker CLI on that specific server, and then you will bring that up, or what else, we can use these tools like Kubernetes or Rancher, which will basically help you to manage these containers when running in large numbers. Next is container host. So host is nothing but our host on which this container is running. So in our case, it is this GitHub code space. So it can be any server on which your container is running. And then container runtime. So whatever is running inside the container, is it malicious or not? What kind of activity this container can do? All these things, monitoring and securing this runtime combines it to container runtime security. Then next is the container repository. So repository is nothing but the place where these container images are stored. So we need to make sure that no one is having permission to push an image, update an image, or pull the image if it is a private repository. So there are two types of repository, similar to how code is stored in the version control. Like it can be a private repo or a public repo. Then container images, as we all know, because this is how the images like containers are created. So we need to make sure that these blueprints, these templates are secure from misconfigurations, or they are following security best practices. There is no hard-coded credentials and all. And these are some challenges. They are self-explanatory, like large attack surface, rapid changes, and third-party risk. So I'll focus more on the third-party risk. There are a large number of registries like this Docker Hub, which hosts third-party libraries. So suppose you were able to pull an image, right, which is backdoored or which is malicious in nature, it can compromise your entire infrastructure. And rest rapid challenges and large attack surface is self-explanatory, that rapid changes because we are doing it very fastly. So we need to make sure that all the images are secure, all the containers running, they have proper fixes or in terms of CVEs or the isolation that is in place. Then large attack surface, as there are thousands of containers running. And the best practices we already covered, like use image security, perform the scan, then follow the security best practice CIS benchmark. You can use tools like Checkoof to scan that, and then monitor it regularly, update any CV which is coming. And then obviously the last part, which is supply chain security. So supply chain security is not only about images, but about the permissions and how the external integrations are happening, or how secrets or their repository credentials are stored. If I'm able to exploit third party repo of some vendor, no, again all the like customers will be affected. Next is layers. So let's talk about Docker images and layers, because we are again and again calling what is Docker image. Like a Docker container is created from the image. So let's look into this. So Docker file is nothing but a set of instructions you write. So whatever, like you mentioned, is created as a layer. So if I'm writing 4 steps, they'll become a layer. So this is how the update frequency goes. So first it is the base image, then layer A, B, C. So if you write something on the top of this, it will go as layer D. So Docker image is a blueprint, a template, and you need to have set of instructions on which following which your image will be created. These layers can be reused. So we'll quickly move to the hands-on lab because we have covered so much of theory. So I'll create one folder for you guys. We are doing it for the cleaning and like segregation purpose, that everything looks clean. So I'll create one Docker file. So we are using cat eof basically, because in some cases in reality we actually don't have T or Vim or any other tool. So that is why we need to make sure like nano. So we don't have any tool. If we don't know how to like use these tools, in that case also you can use this cat eof. So it creates one Docker file for me. Now I'll use this Docker file to create an image. So Docker build -t is a tag where my curl is the name of this Docker image which I'm creating, and dot is the current directory. So you can see it is trying to like build this from the Docker file which we gave. And then if I'll do a Docker images, it will list the image which we have created. So it says my curl with the tag latest and image ID and the creation time and the size. Next is how to inspect a layer. So for inspecting a layer, we need to have this Docker history command. It will give me all the output of what is the image and creation time and everything else. So if suppose I want to check for Nginx, what I'll do, it says first of all we don't have Nginx, so I'll quickly go ahead and pull the Nginx image. So let's pull it, and then we can go ahead and like analyze the history of this specific Nginx image. So now if you'll see, this is 2 weeks ago in couple of places, then 39 hours ago. So this means that this Nginx image, the latest one which we have pulled, was updated 39 hours ago, right? Now if you want to run the same image as a container, so if you'll do docker run my curl, you will see it is giving the output of curl. This is not an error, by the way. So let me show you the Docker file. So if you'll see here, it says curl --help. So this is the cmd which is command. So if you want to run the command when your container is running, right, the startup command when your container will run for the first time, this is this command. So here we are passing curl --help. Next is if I want to modify, and this time I'm changing it to curl --, version. So again we created a new Docker file. I'll rerun the same build command again. Now if you'll see, like I am here in this case, you can see the like SHA-256 is not present for other layers, right? Because it already pulled these things and they were present in my local, and like my Docker is reusing these values. So that is why it is not pulling all the layers. Next is this dive tool, which I wanted to show you guys. This is optional. Like I'm not using it on day-to-day basis, but it is a very wonderful tool when you are understanding the internals of Docker image. So let's download and set this up. WA Goodman is the repo name. You can download it from there also. Next is I'll run this dive command, and you can see once I'm passing the image, it is giving me basically like what is the size command, then current layers and layer details and image details as well. It is giving me all the details which are required. Like you can look into each of it and understand what is these values, from where they are coming, is there any sensitive data and all these things. Now if I want to inspect and retrieve the metadata and configurations, first I'll close it. You have to use escape :q and it will quit. And then when I do docker inspect, you can see this is giving me metadata and configuration about the Docker image. Now, if you want to push this, you can use these 3 commands: docker login, docker tag, and docker push. This is not required as we are going to use ECR, and I'll show you how to use ECR in the future sections. So these are some tasks you can, if you want to do, you can do it. I'll move to the next section. So next section is about Docker namespaces and control groups. So what is this Docker namespace? Why it is required? What is this control group? So Docker namespace is basically about the kernel feature where it limits what you can see, while the control groups is the feature of the kernel where it limits how much you can use. So as it mentions in the diagram, this is exactly the same thing. Next is namespaces. So we just saw a diagram. Now we'll go more into theory part, understand these namespaces and C groups. This is extremely important, and this is the place where you test for the boundaries, you test for namespace to namespace breakouts, isolation, and these kind of things. So you need to understand this namespace like end to end. So what is namespace? Namespace is a feature of Linux where it isolates various aspects of the system resources. Like its purpose is to create a environment, a self-organized environment. Let's assume you have a hotel, and inside that there are multiple rooms, and in each room user is there, where each room is isolated using the keys. So you cannot enter into another room unless you don't have keys. So like if you have keys, if you have permission, then obviously you can go. Now we'll talk about real world example. So imagine a hotel with multiple rooms. Each room is isolated with its own keys, and like you have furniture and guest, and then guest cannot directly go inside another room, right? Guest need to have that specific key if it wants to go from room A to B. So what are some namespaces types? So first is process ID namespace. So each container which runs inside the container is having its own process ID. So a container process may have a process ID 1 inside the container, but same container will have a process ID 1000 on the host. And similarly, we have network namespace. So network namespace is the isolation of networking of the container. So container will have its own private IP range, while your host will have a different public IP as well as a private IP. And then mounting namespace is about isolation about the file systems and how these files can be, or how this host mounts can be accessed. And next is user namespace. So user namespace about the user which is present, like the root user, non-sudo users, and all these things. What are control groups? So control group is nothing but the feature where like Linux gives you ability to manage resource allocation and limit whatever processes are running. So suppose there are more than 10,000 processes running by a container. What will happen? It will consume all the resources and other containers will die. So it will lead to a denial of service kind of an attack. So we need to make sure that these memories, network storage, and the CPU is properly allocated as per the usage, right? So we can decide how much a container should use. Let's take a real world example. So like there is a apartment complex, and on that we have one single gym. So there are chances, if there is no limit, one tenant will go and they'll start using all the resources, they'll all start using all the machinery, and others won't get the same equipment, right? So we need to limit this and fix the time slot, that how much each user can get and what they can use and for how long they can keep it. So what are some key features? Memory limiting is one feature, CPU throttling and process limiting is one other. Memory is limiting is how much memory or how much RAM can be used by the container. Then CPU throttling is about how much CPU it can restrict or it can use. And then process is about how many processes can be spawned at any point of time by that specific container. So we can limit to 10, because if we leave a container and suppose it's inside that there is a like a DDoS kind of attack, any code which is doing such kind of attack, it will consume all the resources, right? So why are namespaces and C groups are important? So isolation, as namespaces ensure process isolation and resources are kept separate. This is extremely important. Then resource control group is more about allocation of resources fairly, so that each container is able to use it fairly and no container is deprived of any specific resource. So let's move into the hands-on lab. Let's explore some of the namespaces first. You can continue in the same terminal. You can see C group, IPC, mount, net, PID. These are namespaces. And yes, C group is a namespace as well. So next is we'll start a basic container to see whether the namespace is getting created or not. Let's do a ps-ef and I'll run this command. So this command is not doing anything except it is inspecting the namespaces present on the host. So if you'll see here, it gives me that cannot open directory proc 18108ns. So that means there was a namespace present, although we don't have permission because we are running this command from a non-root user. So if I'll exit from this container, right, sorry, what will happen? Let's run this command again, and this time there is no output because our container is not running anymore. Next is a shared namespace, like between host and container. So how we can share the namespace? So here in the like PID, you pass that specific theme. So here you can see I'm passing host, so it will share the process ID of the host. It's as simple as that. And then when I'll do ps-aux, like it will give me like VS Code, Docker D, Container D. So these are all process which are running on the host, not on the container, because it is a shared host. We are able to see all these things inside a container. Next is C group. So let's look into the C group. I'll just do an exit. I'll run this docker run hyphen PIDs limit to. So here I am limiting the process IDs to 2. And when I'm doing that, you can see it is saying cannot fork or resource temporarily unavailable. So similarly, if I want to restrict the memory and CPU utilizations, what I can do, I can simply run memory 256 MB and CPU is 0.5 docker stat. So if I run a docker stat into another window, you can see my CPU is like less than no here it is less than 50% and memory usage is 256 MB. So this completes our Docker namespace and C group. Now we'll talk about the Docker secret and performing the static analysis. So let's move on to the hands-on lab section. I'll just close this one and I'll exit. I'll just do a CD so that I'm in the correct directory. So swarm is just a mode to initialize Docker swarm init so that we can test this secret service. So I'll initialize this. You do not need to worry because in reality we do not use Docker Swarm, like especially in the Kubernetes, not in reality. It's more like from the infra point how current infra works. In most cases, I have never used this Docker Swarm. I'm just using it for the lab. So I'll create one secret file. I'll paste the secret inside that, which is secret.txt, and the content is my super secret password 123. And then I'll create a secret. And I've also never used this secret. I'm just showing you guys. In Kubernetes, we have Kubernetes secret, and we use it a lot because in most of the organizations, Kubernetes is used. Or in the case of cloud, like you can use it like Secret Manager or HashiCorp Vault or other similar tool. Let's try to list this secret. So Docker secret ls will list the secrets, and then you can use this secret via service. So let's create a service. So Docker service create the name of the service and the secret. By the time it creates, let's try to list the created service, and it is when I'm doing Docker service ls, it is listing the service. And now if I want to get the container ID, I'll use this command which is using this filter, and it will give me the container ID. This is in case where you have thousands of containers and you don't know, like there can be containers with similar names. So that is why I'm using the filter. In reality, you can just do, for now, if I'll do Docker PS, it will still give me the same. So this is the name, secret.service. And when I'm doing this Docker exec, so I'll re-show you guys. So when I'm doing Docker exec -id and then ID of that specific container and doing a cat inside that, you can see I'm able to list the secret very easily. So that is why it is not recommended. Although you can use a secret manager for storing the passwords and sensitive data. Now I'll quickly go ahead and remove the service, remove the secret, and remove the secret. This is just the cleanup process. As we'll move forward, we'll clean some of the things, and later we'll clean all the images which we put. So next is static analysis of Docker containers. So what is static analysis? In static analysis is inspection of container images for misconfigurations and vulnerability. We are inspecting container code configurations and dependencies. So what usually we need to scan? So first is Docker file, second is the base image, third is the dependency, like the third party dependencies and the libraries which are getting installed. Fourth is the export port. We need to make sure that which port is exposed and whether any unauthenticated service is running or not. Then the sensitive data and the secret data. And these are some common tools: Trivy, Docker Scan, Anchor, and Claire. Although I'm not going to use these tools because they are commonly used, you will find multiple resources. I'm going to use Dockly and Hedulint and Docker Bench Security. Let's complete this part where we'll use Dockly and Hedulint. So I'll move into a directory. So here there is not much to do. And then we will install the Dockly. You can see it's God with Tech Dockly, good with Tech, sorry. So you can just download it from this repo. If you'll search Dockly GitHub, you'll get the repo and you can download it. Now I'll pull the image which I want to scan. Now the next command is Dockly Nginx latest. So it is similar to dive. So it will take some time and it will perform the scan. You can see it is giving me fatal, do not store credentials in the environment, warning and info. So you need to suppress and exclude these kind of false positive, because I can see like this is much more of a data. Although it is having some GPG keys, but it is not having secret or any specific secret or sensitive value. So this is how you perform a Dockly scan. Next is Docker pull Hedolint. So we'll use this Hedolint image this time to perform the scan. And most of these commands are already present in their official repository, so you can go ahead and check this out. Again, we'll create a Docker file for performing the scan. I'll just pass the same Docker file. So HeadoLint is more of a linter where it checks Docker file for like security best practices. So we have to pass this Docker file. So you can see it is giving me DL3007 saying using latest is prone to error. And in the future labs, by the way, we will be looking into this specific error, that what is this latest tag and why it is not recommended to use the latest tag. So we'll be explicitly looking into this. And then there is DL3008 pin versions in the apt install, and 3015 and 3009. So suppose I want to skip or exclude any specific issue which is coming, I can pass this hyphen ignore and pass that. You can see 3008 is not present in this response. So now I'll go ahead and quickly remove the images which we pulled just to keep things clean. I'll also remove this doc.lib. I'll also remove this Docker file and HeadoLint. So you do not need to worry because you have already forked the repo, and this website eksecurity.kubernetesvillage.com is always hosted. So you do not need to save anything anywhere. You do not you can just go into this website, clone this repo. If you already have this repo, you just need to resync it and start working. Next is a Docker bench security tool. So again, since we are already present, you do not need to change the repo, but directory, but still I'll do it because the command is mentioned. So I'll quickly go ahead and clone this specific repo from Docker security bench, and then I'll do a cd. And from here again, I'll give the executable permission, and then I'll go ahead and run this Docker bench script as a root user, because this will run multiple checks, so it needs permission. So you can see the result is completely different from other results. And here in this case, there are so many warnings, information, note, and pass and all, right? So this is happening because this is not a production, and like in most of the organizations, company rely on EKS, and that's why we are bringing EKS Goat. However, to set the background, however, to make sure that the basics are clear, I am making sure that we know what are these issues, what are these outputs. Like you should look into all these outputs and understand why something is an issue, because whatever is issue in a Docker is definitely going to create problems in the Kubernetes security as well. So we need to make sure that these things are fixed if it is required. If it is not required, obviously you can leave it like that, mark it as exception. It completely depends on your organization and your context. This is not something which is user specific, but it is very contextual based on different organizations where you are working. However, you should definitely run these tools, try to find out the different attacks and different scenario, how these things can be exploited and so on. So now I'll do a cd and remove this cloned Docker bench security repo, and I'll remove all the images which are present, and I'll basically stop all the containers as well. So I already stopped the container. I'll remove the images. So this completes our basics of container and Docker, including Docker security, as well as setting up GitHub code space. So this is pretty much it from my side. In the next section, Anjali will guide you through AWS ECR and AWS EKS fundamentals, where we'll talk about authentication and authorization in EKS, and role-based access control, and obviously ECR basics, how ECR performs the scan, what are some security features of the AWS ECR. So these things are highly required. And in the next session, let's discuss more onto the AWS part, and before we deep dive into the attack section. So thank you guys.